Ahoy, everybody. It's Mr. C with your angles and a triangles notes. I'm just going to explain through the notes today. They're really not anything super crazy, and it's stuff that a lot of you have seen before. So I'm just going to get right to it. So we know that triangles have angles inside of them, and an angle is formed by two rays. Remember, a ray from elementary school is where you have the endpoint and the line that continues forever. It's two rays that come together at a common endpoint, meaning here, called the vertex. When they meet at the same point, we call it a vertex. Okay? There's two types of angles. We've got complementary angles, which are 90 degrees, two angles that equal 90 degrees. So, for example, B plus A would give us 90 degrees. So, if angle A is complementary to angle B, and angle B is 23, all we'd have to do is take 90 degrees, subtract away 23, and we'd be left with the measure of angle A, which would be 67 degrees. The other type of angle that we want to talk about is called a supplementary angle. And a supplementary angle is two angles that add together to get to 180. So it's kind of cool because a straight line, wow, that was the worst straight line imaginable. A straight line would just be exactly 180 degrees. Okay, when we go around, it'd be like putting two right angles together to get 180 degrees. Okay, so if I've got these two supplementary angles, we've got an obtuse angle of 130 degrees, and we've got unknown x degrees. What we're going to do is take 180 minus 130, and we'll get 50 degrees for the missing angle. Okay? You guys know the types of angles as well. You know acute angles are very acute. They're less than 90 degrees. They're smaller angles. Okay? Right angles are exactly 90.0 degrees. No bigger, no less. Exactly 90.0. Obtuse angles are the big angles that are bigger than 90 but less than 180. A straight angle is like what we just talked about, a straight line, and it gives you 180 degrees. And then the last thing that I want to talk about is called a congruent angle. It's two angles that are equal to one another. Okay? All right, talking about triangles. So a triangle is a figure with three sides and three angles. Okay, very good. Elmo would be very proud of you for remembering what a triangle is. Okay, triangles have three sides, three angles. We can classify triangles based on their angles that are on the inside. An acute triangle has three acute angles inside of it. Okay, and they all add up to be 180 degrees. That's on the next page. And you probably already know that as well. A right triangle has one right angle, meaning one angle is exactly 90 degrees. It's usually marked with this little square that's in the corner, and that means exactly 90 degrees. Okay, if it is not there, you should not ever assume that the angle is 90 degrees. You should always double check if that picture is not there in the corner. Okay, and take a note, there is one right angle inside of that. The other two are acute angles. That'll be important later to note that if we've got something that's a right triangle or an obtuse triangle, the other two angles must be acute angles. It cannot be anything else. Okay, an obtuse triangle has one obtuse angle, meaning bigger than 90, and then the other two angles are exactly acute angles. They have to be acute angles. It cannot be anything else. Okay. We can also classify by their sides. An equilateral triangle, meaning all of the sides are equal. These little hash marks in the side mean that the length of the side is identical. They're the same. They're congruent. Three congruent sides. I also like to note right here, when we're talking about equilateral triangles, there's also something very special that happens. Because all the side lengths are the same, all of the angles on the inside also are the same. Well, we know that there's 180 degrees in a triangle, so take a quick little mental note here. If these angles are all equal, we take 180 divided by 3, and it gives us these acute angles in an equilateral triangle. They are always, always, always going to be 60 degrees. Every last angle in an acute equilateral triangle are going to be 60 degrees. Okay. Oh, sorry. I was drawing a Star Destroyer from Star Wars there. I'll get rid of those. So the next one is an isosceles triangle. An isosceles triangle has two congruent sides. Those little hash marks in the side, meaning that they are the same length. I also want to note that the opposite angles are congruent as well. They could be a couple of different things, but these two angles, again, are always going to be acute angles in the corners of an isosceles triangle. The ones that are equal have to be acute angles. Okay, the last one is a scalene triangle. I think this is the coolest one because all of the sides are different lengths. Okay, it means all of them are completely different. 0 congruent sides. I put these little hash marks in here because typically once you get higher on in math, you'll see triangles denoted like this to be very abundantly clear that the lengths are different. Okay, the next thing I want to show you is about these triangles. Doesn't matter what kind of triangle it is, all of the angles will equal 180 degrees when we add them all up. That's something that's really special about triangles. So let's consider the following. If I add angle X plus angle Y plus angle Z, I'll get 180 degrees. Okay, 180 is the big number that we've got to memorize here. So let's take a look. If I want to find angle X, there's two ways I can do this. I can either write this whole equation out and plug and chug, which is what I did on the second example, or I can take 180 degrees and subtract the two angles that I know. The reason I show you this is sometimes they'll have a different way for you to find one of these two angles. So I want to show you this way too, so that way you're at least familiar with this process. I can take the total 180 degrees minus the 38, and I get 142 degrees. Then I subtract away the other angle that I know, 55 degrees, and I'm left with 87 degrees for angle X. Remember what I told you about right triangles? This looks like a right triangle, but do we see the little denotation here in the corner? No, we don't. So we cannot assume that this is a right triangle. We have to check. Okay? You've got to do the math, and you've got to make it work out. If it ends up being 90 degrees and there's no marker there, that's totally fine. However, we cannot assume that it's 90. If we would have assumed this is 90 degrees, we would have got the question incorrect. Okay? Let's take a look at this guy. I use the equation on this one to show you that it works out to be the exact same process. If I do angle X plus angle Y plus angle Z, if I do angle X plus angle Y plus angle Z, I get 180 degrees. Mr. C, does it matter which one's angle Y and angle Z down here? Not really. I like to keep angle X the same as this X, so that way I don't confuse myself, but you can really put them wherever you want to. You're just assigning the letters yourself. So I did X plus 42 for Y plus 51 for Z, and that equals 180. You could subtract 51 first, then subtract 42 from both sides, and you'd have X by yourself, or you could combine these two to get 93, subtract away 93 from both sides, and then you end up getting X equals 87 degrees. Okay? On the last one, you could do 180 minus 141, then minus your 17, and you'll end up getting 22 degrees for X. Okay? This last one down here is super cool. An acute equilateral triangle can be divided in half with a segment from a vertex to the middle of the opposite side. What types of triangles are formed? What are the angles measured of the two new triangles? So take a look. I told you equilateral triangles have 60 degrees in each of the angles. Well, when I split it up and I separate the two, I put one over here and I put one over here. The top angle will get split in half to 30. The corners actually stay the same at 60. And then we'll have to figure out what's right here. Well, if I do 180 minus 30 minus 60, I get exactly 90. We get a right triangle. What are the angle measures of the two new triangles? Well, we've got a 30-degree angle at the top. We've got a 60-degree angle on the bottom, and we've got a 90-degree angle in the bottom corner. So we form two congruent right triangles. All right, guys, we've reached the end of our lesson. You have everything you need to be successful with this homework. Good luck, and I hope this lesson helped you. Catch you later. Peace.